Hi, in this video we are going to implement the insert method for the red-black tree data structure. So we get an integer data. First we have to create and instantiate a new node because we are going to store the data in the tree nodes, of course. So we instantiate a new node with the given data. Then we have to insert, so the new root after the insertion is going to be the return value of a method. So insert into tree, we have to specify the root node and the node. And after we insert the given data, we have to check whether the red-black properties have violated or not. So we just fix the violations starting at the node. Okay, in this video I'm just going to implement this insert into tree method. I'm going to rename it to node, or maybe, okay, it's going to be the root node of the actual subtree. It's going to be just fine. And basically we have to check that if the root node is equal to a null, then basically we just return with the node. So this is how we instantiate the root node. Okay, anyways, we are going to return with the root node. And okay, if the node.getData is smaller than the root.getData, it means that we have to visit the left subtree in a recursive manner. Okay, so we just set to root.setLeftChild, and we call this insert into tree method recursively on the root.getLeftChild, and the other parameter is going to be the node. And then we have to set the root.getLeftChild.setParent to be equal to the root. Okay, so why do we have to bother about it? Because we store a reference to a parent node, and this parent node is crucial when we are going to fix the red-black tree, in the sense that if we have violated the red-black properties, then we definitely need this parent in order to check whether these properties have been violated or not. Okay, first of all, recursively visit the left subtree, but we have to set, so root get left child, and we set the get left child's parent to be equal to the root node. Okay, and else if the node get data is greater than the root.getData, it means that we have to visit the right subtree in a recursive manner. So root.setRightChild, and we have to call this insert into tree method recursively on the root.getRightChild and the node. Okay, and after we have inserted it, we have to set the parents as well. So get the right child and set the parent to be equal to the root node. Okay, and basically that's all about the insert into tree method. We are going to need the left rotation and right rotation in order to be able to make the fix violation method. Thanks for watching.